Using electrical networks in residential wiring offers both advantages and disadvantages. Let's delve into the details. Firstly, consider the advantages. One major benefit is cost savings. Using a network configuration can save on wire costs, especially if the rooms are far apart. Secondly, you can see reduced labor. Pulling multiple conductors through walls and ceilings can be time-consuming. Networks simplify the installation process. Thirdly, increased flexibility is another factor. Networks allow for easy reconfiguration if the room usage changes in the future. Fourthly, improved fault isolation occurs. If one conductor fails, it will only affect the devices on that branch, not the entire circuit. Now let's discuss the disadvantages of using networks in residential wiring. The first main concern is voltage drop. The shared neutral conductor can experience voltage drop, especially if there are high loads on both branches. This can lead to flickering lights or reduced appliance performance. The second is code compliance. Some jurisdictions may not allow the use of networks for certain circuits, such as those supplying critical loads. Thirdly are the safety concerns. Improper installation or maintenance of networks can create safety hazards such as overheating or arcing. So, what considerations should you keep in mind when using networks? Firstly, circuit load. Calculate the total load on the circuit to ensure that the wire gauge is sufficient. Secondly, wire length. Long wire runs can increase voltage drop. Use larger gauge wire for longer distances. Thirdly, code compliance. Check local building codes to determine if networks are permitted. Fourthly is installation quality. Ensure that the network is properly installed and maintained to minimize safety risks. Now let's get into more detail about the advantages. Cost savings are a significant driver for using networks. Instead of running individual 12/2 or 14/2 cables to each room, a single 12/3 or 14/3 cable can serve multiple rooms, sharing the neutral conductor. This reduces the overall amount of cable needed, especially in larger homes. For example, imagine wiring 2 bedrooms that are located relatively close to each other. Instead of running 2 separate 12/2 cables back to the electrical panel, a single 12/3 cable can be run, with the red and black conductors each feeding a separate bedroom and sharing the white neutral conductor. This can result in substantial savings, especially when considering the rising cost of copper wire. In addition to cost savings, networks can also reduce labor. Running multiple cables through walls, ceilings, and floors can be a time-consuming and physically demanding task. By using a network configuration, the number of cable runs is reduced, which can significantly speed up the installation process. This is particularly beneficial in new construction or renovation projects where time is of the essence. Reduced labor also translates to lower installation costs, making networks an attractive option for budget-conscious homeowners. The increased flexibility offered by networks is another compelling advantage. In today's homes, room usage can change over time. A bedroom may become a home office, or a living room may be converted into a playroom. Networks allow for easy reconfiguration of the electrical system to accommodate these changes. For example, if a bedroom is converted into a home office, additional outlets or circuits may be needed. With a network configuration, it is relatively easy to tap into the existing 12/3 or 14/3 cable to add new outlets or circuits, without having to run a completely new cable back to the electrical panel. This flexibility can save time and money in the long run, as the electrical system can be easily adapted to changing needs. Improved fault isolation is another important benefit of networks. In a traditional wiring configuration, if a fault occurs on one circuit, it can potentially affect the entire electrical system. However, with a network configuration, each branch is isolated to some extent, so a fault on one branch will not necessarily affect the other branches. For example, if a short circuit occurs in one bedroom, it will only trip the breaker for that particular branch, while the other bedroom will continue to have power. This improved fault isolation can help to prevent widespread outages and make it easier to troubleshoot electrical problems. Now, let's move on to the disadvantages of using networks. Voltage drop is a major concern with shared neutral configurations. When multiple circuits share a neutral conductor, the current from each circuit adds together in the neutral conductor. If the total current in the neutral conductor is too high, it can cause voltage drop, which is a reduction in voltage at the outlets. Voltage drop can lead to flickering lights, reduced appliance performance, and even damage to sensitive electronic equipment. To minimize voltage drop, it is important to carefully calculate the total load in the circuit and use the appropriate wire gauge. Longer wire runs are more susceptible to voltage drop, so it may be necessary to use a larger gauge wire for longer distances. Also ensure that all connections are tight and secure to minimize resistance and voltage drop. Code compliance is another important consideration. Some jurisdictions may not allow the use of networks for certain circuits, such as those supplying critical loads like smoke detectors or life support equipment. It is essential to check local building codes to determine if networks are permitted for the intended application. If networks are not permitted, dedicated circuits must be used for each load. The electrical codes are in place to ensure the safety of electrical installations, and it is important to comply with these codes to avoid potential hazards. Safety concerns are paramount when working with electricity. Improper installation or maintenance of networks can create safety hazards such as overheating or arcing. Overheating can occur if the neutral conductor is undersized or if the connections are loose or corroded. Arcing can occur if there is a break in the insulation or if the wires are not properly connected. Overheating and arcing can lead to fires or electrical shocks. It is important to use proper wiring techniques such as making sure that all connections are tight and secure, and using the correct type of wire and connectors. Also, regular inspections and maintenance can help to identify and correct potential problems before they become safety hazards. Sizing the circuit load is an important aspect of network design. The total load in the circuit must be carefully calculated to ensure that the wire gauge is sufficient to carry the current without overheating. The load calculation should include all of the devices that will be connected to the circuit, such as lights, appliances, and electronic equipment. The National Electrical Code, or NEC, provides guidelines for calculating circuit loads and selecting the appropriate wire gauge. For example, NEC Table 310.15b16 provides ampacity ratings for various wire gauges based on the type of insulation and the ambient temperature. It is important to consult the NEC to ensure that the wire gauge is adequate for the intended load. Wire length is another important factor to consider. Longer wire runs can increase voltage drop, which can negatively affect the performance of electrical devices. The longer the wire, the greater the resistance, and the greater the voltage drop. To minimize voltage drop, it may be necessary to use a larger gauge wire for longer distances. The NEC provides guidelines for calculating voltage drop and selecting the appropriate wire gauge. For example, the NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Online voltage drop calculators can also be used to determine the appropriate wire gauge for a given wire length and load. Installation quality is critical to the safety and reliability of electrical networks. All connections must be tight and secure to prevent overheating and arcing. The wires must be properly insulated to prevent short circuits. The network must be properly grounded to protect against electrical shock. It is important to follow all applicable electrical codes and standards when installing a network. Hiring a qualified electrician is recommended to ensure that the network is properly installed and maintained. In general, it is recommended to use dedicated circuits for each room if possible to avoid potential voltage drop and safety issues. However, if cost constraints or other factors necessitate the use of networks, proper sizing, installation, and compliance with code requirements are essential. This means carefully calculating the circuit load, using the appropriate wire gauge, ensuring that all connections are tight and secure, and complying with all applicable electrical codes and standards. It is also important to educate homeowners about the potential risks and benefits of networks, so that they can make informed decisions about their electrical systems. By carefully considering all of these factors, it is possible to use networks safely and effectively in residential wiring. Using a shared neutral can create what is called a multi-wire branch circuit, which is where two ungrounded conductors share a common neutral. If the ungrounded conductors are fed from different phases, the neutral will only carry the imbalance. However, if both ungrounded conductors are in the same phase, the neutral carries the sum of both, which can overload the conductor. It is best to use a two-pole breaker to feed a multi-wire branch circuit. You would connect the hot wires, one to each pole, then connect the neutral to the neutral bar, and finally the ground to the ground bar. When working on multi-wire branch circuits, it is always a good idea to check the voltage from hot to neutral and hot to hot. The NEC addresses multi-wire branch circuits in section 210.4. It describes the requirements for these types of circuits, ensuring safety and proper operation.